Kia ora Year 12 and 13. I'm just redoing the last part of question 3e from last year's paper with U substitution, just in case any of you found it pretty hard to follow, done by inspection. This is the question here. So we've got y and t satisfying this differential equation. It doesn't hurt to do a little bit of substitution practice just before the exam anyway. So what I'm going to do here is try to find this integral. But instead of doing it by inspection, we're going to do it like this. Let u equal this thing here. So u is equal to sine of 0.5t. And now what I want to do is replace everything. Instead of having t in it, I want it to have u in it. But k is fine because that's just a constant. So I'm going to differentiate with respect to t, and that will give me 1/2 cos of 0.5t. Now we separate the variables, and we get du is equal to 1/2 cos of 0.5t dt. So what I'm trying to do is replace this and this with something to do with this. So we might as well multiply both sides through by 2 so that I can match that exactly. So we get 2 du is equal to cos of 0.5t dt. And that means that I can rewrite my integral as this. We'll call this thing here, let this equal big I. Okay, I for integral. So I is equal to the integral of k times 2 e to the u du, which equals 2k times that, which is 2k e to the u plus c. And now we substitute back in that u is equal to sine of 0.5t plus c. So there you go. Hope that helps, and good luck for tomorrow.